In this video, we're going to be taking a look at angle bisectors. We're going to take a look at what a bisector is, what that means, and we're going to take a look at how we can use this in helping us solve problems. So let's start off with looking at the definition of an angle bisector. It says an angle bisector is a ray that divides an angle into two angles that are congruent. Let's put a picture with this so we can make sense of it. So let's start off with any angle. So I'll just draw a random angle here. And let's call this angle, so at the vertex, let's say that this is B. And then we'll put a couple more points on here. We'll say this is A. And then here we'll have point C. All right, now the definition says an angle bisector is a ray that divides this angle into two congruent angles. So what that means is we have another ray that is going right down the middle of this angle, exactly splitting it in half. Let me put another point on this last ray, and let's say that this is point D. So what I'm looking at here is the two angles on either side are exactly the same size. We have some notation to indicate that. So if I put little arcs in my angles, when they have the same number of arcs, that tells me that they are congruent. If I want to write this out in a statement, so BD bisects, so I'm going to say ray BD bisects angle ABC. And after it's bisected, that also means that our two halves are the same size. So then angle ABD is congruent to angle DBC. So this symbol in the middle here, they're congruent. Or I could say that they're equal to each other. So I could say that the measure of angle ABD is equal to the measure of angle DBC. In that last piece, that equality statement, that's what we can use to help us write and solve equations when we're working with these angle bisectors. And let's look at an example where we do just that. So I have ray VB bisects angle AVC. All right, before we go any further, let's start with a diagram. So the first thing is I have an angle AVC. So I'm just going to draw that first. I don't know exactly what this looks like, but that's okay. We just want something to help us work through this. So we'll put some points on here. And then the way that this angle is named, angle AVC, the vertex is going to be the middle letter, so it's going to be V. And then we'll say that's A, and this is C. And then the other piece we're given is it says VB bisects, so this is the important word here, VB bisects this angle. So that means we have another ray going right down the middle, and somewhere on that ray is going to be this other point, B. Okay, and because it's bisecting, I know that the two halves are congruent to each other. So right away, I could write out a statement. I could say that the measure of angle AVB, that has to be equal to the measure of angle BVC, right? The two sides have to be equal to each other. All right, if we keep going on our given information, it says that the measure of angle AVB is 5x minus 12. So A to V to B is represented by 5x minus 12 degrees. And the measure of angle CVB, so from C to V to B, so our other half, this is represented by the expression 3x plus 7. So now that I have this picture, I've made sense of what I'm given here, I think we can write an equation. So I already have this equality statement. I know that the two smaller angles, because of the angle bisector, I know that these have to be equal to each other. So substituting in what I'm given, I know that 5x minus 12, that has to be equal to the 3x plus 7. And now that's an equation I can solve. I can find x here. So let's group up our like terms. So I'll subtract 3x from both sides. I'll add 12. So I end up with 2x is equal to, see, 7 and 12, I get 19. And the last step, if I divide by 2, so 19 divided by 2, I am going to end up with a decimal, but that's totally fine. It's just going to be a half. So we end up with 9.5. So I could write that as 9.5, or I could write that as 9 and 1/2, or I could just leave it as 19 over 2. That would be okay. All right, so why don't we find out how big this entire angle is now? So I want to figure out how big the entire thing is. First, I can find out how big half is. So let's take a look at the measure of angle AVB. So now instead of the x, we'll substitute in what we found. So I'm going to plug in 9.5. So if I simplify, 5 times 9.5, I get 47.5. And then from there, I'm going to subtract 12. So I end up with 35.5. Okay? Now, that is also the same as my other half. I could test that out by plugging in x, but because of the way we set up our equation, I know that the measure of angle BVC is also going to be 37.5. So this angle here is, 35.5. And this angle here is also 35.5. Altogether then, I just need to double that to find out my entire angle. So the measure of angle AVC, the entire thing, is just twice as big as 35.5. So for a total, we get 71 degrees. So those are angle bisectors. It goes right down the middle of an angle. It cuts it exactly into 2 halves. If we think about that word bisect, it kind of gives us everything we need to know. The word bi means 2, so we have 2 halves, and that the root of the word sect means to cut. So we're cutting the angle in half, getting 2 congruent angles.